Howdy. Let's work through another example dealing with the equilibrium of rigid body. You can see this is a two-dimensional problem. It's subject to a system of coplanar forces. What we're going to try to do today is going to be to solve the reaction forces at A and B. So let's take a look at the problem here at hand. We have this bent rod, like so, that is welded to a collar over here. Notice the note over here, the collar says it's a smooth collar, so it's free to slide up and down, no problemo. So that's one support over here, a smooth collar. The other support is at point B. Hopefully you can pick it up from my ugly drawing, but this is meant to be a roller. Anyways, we have a bent rod, we have a point load, we have a couple moment, a smooth collar, and a roller. So let's figure out what the reaction is going to be at A and B. So what's going to be the first step? Correct? It's going to be to draw a free body diagram. So let's draw it together here. Horizontal. Then it makes some angle like so. Now it doesn't have to be pretty. More or less, all we need is the outline of the body. The next step is once you have the outline, we're going to put the applied forces or the given forces. So if we go down, there's going to be a force over here of 100 newtons. And there's also a couple moment of 50 Newton meters. So remember the steps: outline of the body, applied forces. Next we need reaction forces. Reactions I like to cover in red just so I know that I'm solving for the reaction forces. I got the smooth collar at A and the roller at B. Let's start with the roller. This roller over here is like, remember when you were a little kid and you had maybe roller blades or roller skates, right? So the question that we're gonna ask is the same thing. Can a roller prevent any translation of the body about the X? So if the only thing that was securing this to the ground was a roller over here at B, do you think it would resist any lateral forces? The answer is no, right? This thing is just gonna roll. So like somebody pushed you and you're on rollerblades, you're just gonna go, right? No problem. The next question is, can you translate up and down, right? Well, if you're on rollerblades, you can jump, no problem. But what you can't do is go through the ground, right? Because the ground, what's it gonna do? It's gonna react. It's gonna put a force back up to bring you into equilibrium. So again, you can jump up, no problem. So there's nothing keeping you from moving up. What you can do is go dig into the ground. The ground is gonna resist and put a force back up over here. So always you're thinking like, what is my body gonna feel? So I cannot drive it down. It's gonna feel resistance from the ground up. Let's call it B. Right, the roller, it's always gonna be normal or perpendicular to the surface. In this case, the ground is horizontal, so this is gonna be just strictly vertical. We're gonna call this BY over here. Now let's go to point A. Over here we have a collar. It is smooth. So smooth means it can slide up and down, no problem. So we're not going to have a force here in the Y. But I hope that you can tell that if I have a smooth collar over here, and this is my rigid body, I can't move in the X direction because the collar is keeping me from doing that. So I need a reaction force in the X direction. I'm not going to think about it too much. I'm just going to assume in the positive X direction. So I'll call this AX. So notice I already have AX and BY. So I'm just going to go ahead and specify, yes, this is going to be the X. This is the Y axis. We're still not done here at the point at A, right? We talked about translations in the X, translations in the Y. Next thing we need to worry about is any rotation. So if I have a collar over here, right, ignoring what other supports in the body is, do you think it would easily rotate? So again, I have a collar. I'm gonna signify here my fist as a collar, and this is that guide rod. So if this is welded, right, hopefully you can tell that I cannot easily rotate. There's no easy pivot. So that means that this guy is going to also prevent some rotations. what am I gonna say is I'm just gonna assume like a positive couple moment and let the equations of equilibrium tell me if I am correct or not, right? So I need a moment here, restoring moment. So I'm just gonna assume positive because counterclockwise is positive. I'm gonna call this MA. This is the moment at A, not MAX. We have outline of the body, applied forces, reaction forces. What else do I need to solve this equation of equilibrium? This problem. I'm gonna need the distances, right? So this is a distance of 1.5 meters to here, another 1.5 meters to right there. And then the length of this guy over here is 1 meter. Like so. And also, this guy makes an angle of 45 degrees. So that angle is 45 degrees. So once we're done with the free body diagram, I can go ahead and look at anything that is written my reaction forces to try to see how am I going to solve it. Well, let's do some accounting here. I have a reaction force in the X. I have a reaction force in the Y, and I have a moment. So although this problem started off a little bit maybe complex because we have this fancy support over here called a smooth collar and a roller, when we do the free body diagram, right? Hey, I have an unknown in the X, one unknown in the Y, and one moment unknown. So what does that signal to me? Hey, if I want to solve the force in the X, right, I'm just going to sum forces in the X direction and make it equal to 0. Again, if a force points in the positive X-axis, I'm going to say it's positive. So I'm going to sweep this free body diagram from left to right. The first force that I see is AX. I assumed it to be in the positive X direction, right? So it's positive. What else do I have? I have a moment, a vertical force, a moment, and a vertical. There's nothing else, right? So the sum of all those forces, in this case just 1, the sum of the forces has to be 0, so the sum of this one has to be 0, which means AX equals to 0. Does it make sense? Yes, I got nothing in the body trying to translate it in the X direction, so there's no need to develop a force in the X direction at the collar. Again, if there was something trying to move it in the X, then this guy would react and we would have a number other than 0. Right now, all we have is AX equals 0. Next one, if we do some of the forces in the Y direction, we make equal to 0, right? Any force that points up is going to be a positive force. So again, I'm going to sweep from left to right. I got horizontal force, I got a moment, and then I have a force, right? So minus 100, y minus, because it's pointing in the negative y-axis. So I got this one. And as I continue sweeping, the only last one is by. By I assume to be pointing up, right? So up is positive, so plus by. And that's it. I got no other forces in the y direction, so the sum of all of that must be equal to 0. We can solve for by super quickly over here, right? Just by adding 100 to both sides of the equation. So by equals a positive 100. Notice the unit is newtons. And remember what this means. Whenever we get a positive answer for a reaction force, it doesn't mean that the reaction force points up. It means the direction that we assumed on the free body diagram is correct. Here, the direction that I assume is up. So now we get confirmation. Yes, by is 100 newtons going up. The next thing I have to figure out is a moment, right? So to solve for that, I'm just going to sum the moments and make them equal to 0. Right? Any moment that is counterclockwise is going to be a positive one. Remember, when we sum moments, I need to pick a point, right? In this case, I'm just going to use the origin over here, or point A is the same thing. So I'm going to sum the moments relative to point A. So as I start summing moments, right, I'm going to sweep from this point A to the right over here to try to cover everything. I'm looking at the force AX over here. It passes through point A, so it's not going to generate a moment. So this guy is gone. Next, I have this couple moment, this reaction at A that can develop. So right now I drew it counterclockwise or positive. So I'm going to say MA right there. Next, as I continue to sweep, I got two. I got a force and a moment. Let's take care of the first of the force. So if the force is 100, right, and it's at a distance of 1.5 meters, it's going to generate a moment, right? This force does not pass through point A. Point A is here, by the way. So we need to account for it. The force is 100. The distance is 1.5 meters. And then what happens, right? If I'm pinning at A and I push down, this guy is going to spin like that. That's a clockwise rotation or a negative moment, right? Because counterclockwise is positive, clockwise is negative. We also have a couple moment there. It's 50. Look at the unit. This is already force times distance, right? So I don't need to multiply this by any distances. It's already a moment by itself, couple moment. The only thing I need to worry about is the way it's rotating, or the way it makes the body rotate. Right now it's in this direction, right, which is a clockwise or a negative moment. So minus 50 because it's a negative couple moment. As we continue sweeping away, the last one that we have is By, right? The force is By. I'll put it here in red because there was a reaction. The force is By. Next, we need to determine the perpendicular distance between By and point A, right? So this is going to be 3 meters plus this distance here. So this is going to be 3 plus, I need to figure out this distance. Well, if this is 1 meter and the angle is 45, so plus 1 times cosine 45 is going to give me the x component. So cosine 45. We got force. All of this in here is distance. The next thing we need to ask ourselves is, will it create a positive or negative moment? So let's see, right? If I put my fist here at the point of interest and I go intersect that force and then curl in the direction of the force, this means I need to put my index fingers like that. That makes it a counterclockwise rotation, so that's a positive moment. There's nothing else, right? So the sum of these 1, 2, 3, 4 moments must be equal to 0, right? Here I wrote By because there was a reaction, but we already know what it is, right? So if we put 100 right there, right, this is given, and we can solve for MA. And if we type that on the calculator, this is going to be MA equals to minus 107.7 Newton meter. Now again, remember, whenever we get a negative for any of the reactions, right, this means that the direction we initially assume is incorrect. So as I look over here, I had assumed the moment at A to be counterclockwise. This is telling me negative, so it's telling me nope, that direction should be opposite. So that means that that reaction moment at A, this is 170.7 Newton meters. Again, not counterclockwise, but clockwise. This is our reaction moment at A. So I hope you found the video useful. If you picked up on any mistakes, please let everybody know in the comments below. Otherwise, we'll see you on the next one.